Stephen Burns presents 3I/Atlas, an interstellar object currently passing through the main asteroid belt. It has a non-zero but extremely small chance of colliding with anything that could change its trajectory, hyperbolic origin, and speed. 3 Atlas asteroids move along a hyperbolic orbit at a speed of about 60 kilometers per second, likely ejected from a distant star system, possibly from the direction of Sagittarius, near the galactic center. Avi Loeb's research suggests that its origin may be linked to a destroyed protoplanetary body around a red dwarf, ejected into interstellar space before it entered our solar system. The size of its nucleus and coma is estimated to be between 1 and 50 kilometers in diameter. However, the coma, rich in carbon dioxide, stretches nearly 700,000 kilometers, which is half the diameter of the Sun, making it one of the strangest interstellar visitors ever observed. Recent images from the Gemini telescope show how the object is forming a faint tail, but it will be harder to observe after October 21st, during the superb conjunction when Earth, Sun, and 3 Atlas satellites align. Although its path crosses the densest area of the asteroid belt just 5 degrees from the ecliptic, the probability of a real collision remains extremely low, about 1 in a billion, though its gravitational and electromagnetic interactions can create captivating dynamic effects during passage. Key dates ahead. The closest approach to Mars will occur on October 3rd, a superior conjunction with the Sun around October 21st, and perihelion, the closest approach to the Sun, will happen on October 29th. These months will be critically important for observations and research, including interactions of electromagnetic fields and the dusty plasma environment. A massive dusty plasma environment around 3 Atlas can interact with the heliosphere and potentially alter the magnetic field of inner planets, creating charged dust flows that may influence solar wind behavior or even Earth's geomagnetic environment if conditions align, serving as a signal for planetary defense. Although the likelihood of a collision with Earth is extremely low, this event underscores the need for early detection, more accurate trajectory modeling, and global readiness for any future objects that may pose a real threat. The mystery of the 3 Atlas, whether of natural origin or, as some suggest, artificial, reminds us of how little we actually know about our cosmic neighborhood and how important it is to keep watching the sky. This object moves along a hyperbolic trajectory at a speed of about 60 kilometers per second and, according to Avi Loeb's research, likely originates from a destroyed protoplanet around a red dwarf in Sagittarius. This suggests that the 3 Atlas moons could be fragments of a long-lost planet, ejected billions of years ago from its home system and wandering through interstellar space until now. Its massive yet mysterious core. The core of the object is likely between 1 kilometer and 50 kilometers in diameter, but direct observation remains impossible due to the surrounding dust and gas, a massive coma, and a plasma cloud. A coma rich in carbon dioxide reaches nearly 700,000 kilometers in width, half the diameter of the Sun, making it extraordinarily active for interstellar visitors and providing scientists a rare opportunity to study its composition. A faint tail forms. Images from the Gemini Observatory in the south show that the 3-eyed Atlas is beginning to form a tail, although it is significantly less pronounced than typical comets, and this tail will develop as it approaches perihelion. Critical chart. October 3rd marks its closest approach to Mars. On October 21st, it reaches its greatest conjunction with the Sun, making the object nearly invisible from Earth, and on October 29th, perihelion occurs, the moment when solar heating peaks and the object's activity may significantly increase. Transport through the asteroid belt and the probability of collision. Its orbit passes directly through the asteroid belt only 5 degrees from the ecliptic plane, meaning it crosses the densest areas of asteroids, yet the actual chance of a strike remains extremely low, 1 in a billion. Nevertheless, gravitational and electromagnetic forces can slightly alter its trajectory. Electromagnetic interactions. The dusty plasma shell of the object can interact with the heliosphere and solar wind, potentially enhancing magnetic fields or releasing charged streams of dust that could affect space weather if they encounter Earth. Implications for planetary defense. Although a direct collision with Earth is nearly impossible, 3 Atlas satellites serve as a cosmic alarm, highlighting the need for improved detection systems, accurate trajectory modeling, and readiness for objects that may pose a threat in the future. Technology and speculation. Some even speculated about artificial origins or alien probes, although natural explanations remain much more likely. Nevertheless, Its passage is one of the most intriguing events in recent astronomical history, reminding us how dynamic and unpredictable our solar system is. The size of the core remains uncertain, possibly ranging from 1 to 50 kilometers in diameter. However, its coma, rich in carbon dioxide, is enormous, about 700,000 kilometers wide, which is about half the diameter of the Sun, a dusty halo, and the formation of a tail. This massive coma consists not only of gas but also of a cloud of plasma and dust, creating a halo that interacts with sunlight and solar wind, slowly stretching into a faint tail, as seen in images from the Gemini telescope in the south. A unique opportunity for study. Scientists use this period before the object passes behind the Sun at the end of October to collect as much data as possible about its composition, behavior, and trajectory. When the superior conjunction occurs, it will be hidden from view. Dynamics of the asteroid belt. The three-eyed atlas moves through the asteroid belt at a slight angle, passing close to the densest areas filled with millions of objects. This increases the likelihood of gravitational or electromagnetic interactions that may slightly alter its trajectory, although a direct collision is highly unlikely. Electromagnetic complexity. The surrounding plasma cloud can cause electromagnetic disturbances, enhance interplanetary magnetic fields, or even create charged dust clouds that spread throughout the solar system, potentially affecting space weather if they intersect with Earth's magnetosphere. Although the chances of a collision with Earth are extremely low, the three-eyed atlas serves as a vivid reminder of why planetary defense programs exist to track, model, and prepare for cosmic objects that may one day pose a real threat, a rare and mysterious visitor. Whether it is just a natural fragment from another star system or something much stranger, its journey through the solar system is a once-in-a-lifetime event, and its evolution in the coming months may reveal secrets about interstellar objects we have never encountered before. On August 27, 2025, observations, for example, using the Gemini telescope, show a developing story, but by approximately October 21st, the excellent connection will hinder observation from Earth, closing the observation window. This short period before the conjunction is the best opportunity for astronomers to capture images and gather data on the three-eyed atlas, as soon it will be behind the Sun from Earth's perspective, and nearly impossible to track until it reappears in a few weeks. The growth of the tail and solar interaction. Its tail, although still weak compared to most comets, is expected to elongate and brighten as solar heating increases, approaching perihelion on October 29th, which may provide more information about its structure and composition. A close approach to Mars on October 3rd provides a rare opportunity for Martian orbital probes to observe the object up close, offering a different perspective compared to Earth and helping to refine trajectory calculations. And through the asteroid belt, unlike most comets with steep inclinations, the three-eyed atlas moves directly through the heart of the asteroid belt, deviating only 5 degrees from the plane of the ecliptic, meaning its path intersects with many known asteroids and could lead to gravitational disturbances or even extremely rare close encounters that slightly alter its trajectory. Incredibility. Still minimal. Despite this overlap, the probability of a direct collision remains incredibly low, about 1 in a billion. But its large size and electromagnetic interactions may still cause changes in the local dynamics of the belt. Electromagnetic effects and dust flows. His massive coma and plasma cloud interact with the solar wind, possibly creating streams of charged dust that can spread through the heliosphere and potentially enhance the influence of space weather if they coincide with Earth's orbit. Lessons in planetary defense. This case serves as a warning signal for scientists and politicians, emphasizing the need for constant monitoring of interstellar objects, conducting simulations of possible orbital changes, and preparing for scenarios where an object may be on a collision course. This is a mystery that captivates the imagination. Although most evidence points to a natural origin, speculations about possible artificial or extraterrestrial technologies continue to attract public attention, highlighting how little we know about objects arriving from the depths of space. The coming months may provide us with answers or leave us with even more questions. The probability of a collision remains extremely low, about 1 in a billion, even considering the large size of the object and its electromagnetic interaction in the asteroid belt. A huge object passing through a dense region. The uniqueness of this passage is that the triple eye of the atlas moves almost perfectly along the plane of the ecliptic, meaning it passes through the densest part of the belt, rather than sliding above or below it like most comets. The potential for close encounters. Even without a direct impact, there is a chance of gravitational or electromagnetic interactions with other bodies which may slightly alter its trajectory and make future encounters with planets or asteroids more interesting or even risky in the long term. Unusual plasma dynamics. Its dusty plasma coma interacts with the heliosphere, and scientists closely monitor how this may affect interplanetary magnetic fields. Such interactions can trigger chain reactions, including the intensification of solar wind turbulence. The possibility of forming dust packets. As the triple eye of the Atlas approaches, it can leave behind charged dust packets that will follow its orbital path. If the Earth later crosses these areas, we may observe geomagnetic storms or unusual auroras, especially if these encounters coincide with increased solar activity. Astronomical laboratory. This event is a living experiment for researchers, allowing them to study interstellar objects in real time, especially how they behave in a new, stellar environment after a multi-million-year journey through deep space, as well as monitoring and modeling their trajectory. Observatories and sky mapping programs constantly recalculate its orbit as new data comes in, refining our understanding and reducing uncertainties about its future path. Long-term consequences. Even if the triple eye of the Atlas passes without harm, it serves as a reminder that not all interstellar visitors will be so benign and that our planetary defense strategies must account for hyperbolic objects that approach quickly and without warning. A rare opportunity for science and imagination, whether it becomes just another fragment of commentary or surprises us with unusual behavior. Atlas's three eyes have already attracted global attention, serving as both a scientific possibility and a humbling reminder of our fragile position in space. They will approach Mars on October 3rd and reach perihelion around November 20th, with an excellent conjunction with Earth and the Sun expected around October 20th. Scientific possibilities of approaching Mars. The close approach of October 3rd provides a rare opportunity for orbital spacecraft, such as MAVEN and Mars Express, to observe the three eyes of Atlas from a unique perspective, potentially capturing high-quality images of its nucleus and coma, as well as even recording gas emissions that ground telescopes cannot see. The issues of the superior conjunction. The superior conjunction on October 20th will temporarily hide the object behind the Sun from Earth's perspective, making direct observations nearly impossible for several weeks. A frustrating but inevitable gap in data collection during the critical period around perihelion. The unknown behavior of perihelion. On November 20th, perihelion will face a true test of his stability. The researchers eagerly await to see if it will brighten, crack, or show unexpected jets when the solar heat peaks, which could significantly alter its appearance in orbit. Predictions. Current models suggest it may become bright enough to be seen in small telescopes after conjunction, although it might remain too dim for the naked eye, depending on how much dust and gas it ejects and how its trajectory is adjusted post-conjunction. As soon as it reappears, astronomers will quickly begin restoring and refining its orbital parameters, as gravitational and ejection effects near perihelion may slightly alter its expected core and tail growth potential. The tail may become more impressive after perihelion as volatile substances continue to sublimate, making the object interesting for astrophotographers and astronomy enthusiasts with the appropriate equipment. Data coordination. Observatories, NASA, ESA, and other space agencies coordinate observations from space telescopes like Hubble and JWST, striving to collect spectroscopic data on its composition before and after perihelion to compare changes. Although the likelihood of a collision remains low, scientists emphasize the importance of continuous monitoring of Atlas's three eyes, as its path through the solar system serves as a natural stress test for planetary defense systems and provides an opportunity to improve our ability to detect and characterize fast-moving interstellar objects in the future. Although the probability of a strike on Earth remains minimal, scientists emphasize the importance of observing such objects. Objects modeling potential interactions, gravitational, electromagnetic, dust, and plasma, require readiness, regardless of their natural or hypothetically artificial origin. Protecting the planet is becoming a crucial task, and the likelihood of an object with a 1 in a billion chance passing through the solar system is a sufficient reason to test our detection systems, refine orbital prediction models, and practice global coordination in response to potential collision scenarios in the future. Interdisciplinary modeling. Scientists conduct complex simulations to understand how the passage of an object named Tri-A Atlas might slightly affect nearby asteroids or create dust streams that could cross planetary orbits in a few years, raising speculation about artificial origins. Although the data convincingly indicates a natural origin, Burns acknowledges that the possibility of artificial construction, such as an abandoned probe or a fragment of alien technology, cannot be ruled out without further observations, fueling public imagination and philosophical questions about cosmic neighbors. The necessity of early warning systems. This meeting emphasizes why space agencies invest in next-generation telescopes and observation programs capable of detecting faint, fast-moving interstellar visitors long before they arrive in the inner solar system. Readiness of technologies and research on deflection. In addition to monitoring, this event renews interest in research on mitigating collisions, from kinetic impactors to gravitational tractors, providing humanity with real options if a dangerous object is ever detected on a collision course. Electric interaction and education. Burns emphasizes that by making these discoveries accessible to the public, we inspire global curiosity and remind humanity of its shared responsibility for the planet's safety, turning abstract science into a unifying mission. The expansion of the search for life. Meetings of this kind are also related to a broader search for life, as interstellar objects may carry material from other star systems, offering clues about the prevalence of habitable conditions beyond our sun, which is a call for wonder and vigilance. Whether it is the three-eyed atlas, simply a cosmic guest, or a messenger from another system, it presents us with the task of remaining curious, prepared, and expanding our horizons. If you want to learn more about the mysteries of space and our psychological place in it, subscribe to the channel, like this video, and share it with those who love to ponder global questions, because the universe continues to write its stories, and we are just beginning to read them.